They say air has no memory, but every breath we take is older than our species, older than the continents that shaped our names. It carries the dust of forests that no longer exist, the size of oceans that once boiled with unseen life, the faint smoke of forgotten fires. Somewhere within that thin film of sky, barely a sliver against the void, lies the story of how life first learned to breathe too much. So, before you get too comfortable, take a moment to like the video and subscribe, but only if you really like what I'm doing here. And as you listen, tell me where you are and what time it is where you're breathing right now. The world, once, was drowning in air. 35% oxygen, a number that sounds harmless, almost nourishing, until you realize that fire and flesh no longer kept their distance. Every spark became a storm. Every inhale carried the potential for ignition. What we call the Carboniferous was not a calm Eden of green, but a furnace disguised as paradise. Forests rose higher than cathedrals, their trunks wrapped in endless spirals of ferns and moss. Swamps glowed beneath perpetual twilight, their water thick with the scent of decay and renewal. Fossils tell us that insects the size of hawks hunted over those bogs. Dragonflies with wings nearly a meter wide glided through clouds of mist. Centipedes the length of cars pressed their armored bodies through the spongy undergrowth. Everything was swollen with air. The planet itself seemed to be breathing faster, like an animal on the verge of fever. Geologists call this the Great Oxygenation of the late Paleozoic, but such words barely capture its strangeness. It began quietly, with plants, primitive trees, lycopsids, horsetails, seed ferns, found a new trick, burying carbon. When dead wood fell into the swamp, it sank instead of rotting. Fungi, which had not yet evolved the enzymes to digest lignin, could not finish the cycle. So the planet's carbon, the skeleton of its plants, was sealed underground. Oxygen, released during photosynthesis, had nowhere to go but up. Slowly, invisibly, the air changed. It happened over millions of years, yet the world must have felt it like a creeping intoxication. Lightning became more dangerous. Fire, once rare, became routine. Charcoal layers in ancient rock show the scars of endless burning. But fire was not just destruction. It was renewal. Each flame cleared space for new growth. In that balance of growth and ash, the planet found rhythm, a pulse of breath that sustained abundance. And yet, something about it feels unsustainable. Too much of a good thing becomes its own form of decay. Oxygen in excess is corrosive. It does not only feed fire, it also burns from within. Modern biologists understand this as oxidative stress, the slow erosion of cells by the very molecule that keeps them alive. In a 35% atmosphere, that stress would have been constant. The air itself was both medicine and poison. Imagine breathing that world, each lungful richer, denser, more exhilarating than ours. The blood of every creature ran hotter, brighter with oxidation. Energy came easily, but it cost something subtle. Fragility. The smallest wound might fester faster. The lightest spark might erase a forest. Abundance was danger in disguise. The rocks remember what life cannot. They whisper of a world where air pressed heavier against skin, where insects did not need lungs because oxygen slipped into them by diffusion alone. No pumping, no effort, just effortless burn. That is why the dragonfly could grow large enough to cast a shadow like a bird. Its tracheae, those delicate tubes that carry air into insect flesh, were once wide highways of gas exchange. The air did the work. Life simply followed. We call it adaptation, but sometimes it feels more like surrender. The planet offered a gift, too generous to be stable, and life accepted, not realizing that every breath brought it closer to collapse. Evolution is rarely merciful. It builds cathedrals only to let them crumble. When the atmosphere thickened with oxygen, it was as if the world inhaled too deeply, and the exhale would take millions of years. Scientists studying coal seams from that era find trapped bubbles of ancient air, tiny capsules of the past sealed inside the black bones of forests. The gas composition tells a simple story. An atmosphere climbing toward 35% oxygen, then slowly, inexorably falling. Each shift leaves traces in fossilized charcoal, in isotopic ratios, in the thickness of growth rings frozen in stone. From these whispers we reconstruct an age that seems impossible. A world almost too alive for its own good. But there is something more mysterious beneath the data. How could such equilibrium exist at all? What prevented the planet from crossing the line into total combustion? With so much oxygen, every lightning strike should have lit the sky for centuries. Yet the world did not burn entirely. There were self-limiting forces, perhaps moisture, perhaps the geometry of forest canopies, that tamed the flame just enough to let life persist. It feels almost intelligent, as though the biosphere itself learned restraint through pain. We cannot know how it looked, not exactly. But there are hints in the fossils of lepidodendron, the towering club mosses that reached 30 meters high, their diamond-patterned bark preserving the signature of a lost humidity. Their trunks grew fast, hollow, filled with spongy tissue that carried water upward like veins of a living cathedral. In their shadow, amphibians swam through peat pools, their skin breathing in the same thick oxygen that once made the sky glow faintly green. That color, some say, was not metaphorical. High oxygen concentration can shift the scattering of light, giving the air a faint turquoise hue when the sun set through haze. Perhaps the Carboniferous twilight shimmered in shades we can no longer imagine. A visual echo of chemical abundance. Every epoch begins as an accident and ends as a correction. The oxygen spike was both gift and warning. Fire became the teacher, sculpting landscapes into balance again. Charcoal buried under layers of sediment became coal. Coal, in turn, became the memory we would one day dig back up. The forests of that age, unaware of their destiny, were already shaping our future breaths. When the air finally began to thin, the giants faltered. But that comes later. For now, we are still in the moment when the world's lungs are full, when every gust of wind carries the scent of creation and combustion intertwined. It is a reminder that balance is never still. It oscillates between extremes, like the quiet rise and fall of your chest as you drift toward sleep. The breath before memory, thick, luminous, dangerous, still lingers in every exhale we give back to the world. And though we no longer see dragonflies the size of birds or trees that pierce the clouds, the chemistry that made them possible still moves through us, particle by particle, like an ancient dream repeating itself in the modern wind. The air was alive with green thunder. Beneath the heavy canopy, the first forests breathed with an intensity that bordered on fever. Every frond, every moss, every towering lycopsid exhaled the invisible gas that would one day shape all consciousness. The planet itself seemed to be learning the rhythm of respiration. Inhale, exhale, flame, renewal. No creature, no mountain, no ocean escaped that slow synchronization. The Carboniferous world was not merely lush. It was electric. Light scattered through misty jungles where humidity turned sunlight into liquid. The soil was not dry ground, but an endless sponge of decaying matter. Thick, fragrant, alive with silent decomposition. The forest stretched across entire continents, unbroken walls of life stretching from what we now call North America to the heart of Eurasia. Every leaf that fell became food for another root. Every root was a vein for the planet's slow heartbeat. Oxygen poured into the sky faster than the rocks could absorb it. Geologists studying coal seams call this the green engine, a planetary experiment in photosynthesis pushed to its natural extreme. The very air began to glow, its chemistry altered by relentless respiration. Oxygen was no longer a trace gas. It was an active participant in the biosphere, a sculptor of fate. Scientists reconstruct this era through the isotopic ratios of carbon and sulfur, measuring the story locked inside molecules smaller than dust. But for all the numbers and diagrams, they cannot describe how it must have felt to live in that dense, living atmosphere. A world where even breathing was an act of abundance. Insects ruled the sky. They did not need lungs. Air slipped through their tracheae like music through a flute. Dragonflies hovered over shimmering wetlands, their wings veined like stained glass. Below them, millipedes the length of serpents wound between towering roots. Amphibians croaked in thunderous choruses across shallow pools, their voices echoing through the green haze. To them, oxygen was not just sustenance. It was expansion itself. The very fabric of life stretched outward, testing limits no creature had ever known. And yet, somewhere in that perfect balance, a quiet instability began to hum. Too much air, too much light, too much fuel. The forests, now saturated with oxygen, became tinderboxes waiting for a spark. Lightning became prophecy. A single bolt could ignite an entire valley, turning damp ferns into pillars of flame. The earth was learning its most dangerous lesson, that breath and fire are siblings. In the fossil record, layers of charcoal testify to this new rhythm. Firestorms that swept through swamps and returned, again and again, in patterns almost seasonal. Scientists examining those ancient layers find something haunting. Even as forests burned, they always grew back. Stronger, denser, richer. Fire fertilized the soil with ash, releasing minerals and fixing nitrogen back into the ground. It was as though the planet was conducting a vast, self-correcting experiment in destruction and renewal. To imagine it now is to see contradiction embodied. The same fire that devoured the forest ensured their resurrection. The same oxygen that fed their growth made them vulnerable to annihilation. The world had discovered a paradox so elegant that it would echo through every future age. That survival requires the possibility of death. Deep within those forests, photosynthesis rewrote the climate itself. Carbon dioxide levels dropped as oxygen climbed. Global temperatures cooled slightly, altering wind and rain patterns. Swamps expanded. Glaciers advanced at the poles. The earth was reshaping its own lungs, finding a balance between suffocation and combustion. Every living thing became an instrument in that orchestra of gases, a harmony so vast that even the continents seemed to sway to its pulse. But not all creatures thrived. Some species began to shrink as the air grew too potent. Oxygen, in excess, disrupts internal chemistry. Proteins oxidize faster. Cells accumulate damage. For small creatures, it meant vitality. For larger ones, it meant limitation. The balance between oxygen supply and metabolic demand became a hidden law of evolution. Those who could moderate the burn survived. Those who could not vanished. Modern scientists simulate these dynamics in sealed chambers. They raise insects in enriched oxygen to test their limits. And again, the results echo the past. With each % increase in O2, wings widen, thoraxes expand, but lifespan shortens. Growth is easy when energy is free. Endurance, less so. The Carboniferous forest was a playground for giants but a tomb for stability. Still, in its own way, it was paradise. A paradise without stillness. Picture the vast trees of the genus Lepidodendron, their trunks patterned with diamond scars, each one marking the ghost of a fallen leaf. These trees were hollow, built for speed rather than permanence. They grew fast, reached high, and collapsed often, feeding the ground that had birthed them. Around their roots, fungi wove white webs through the peat, waiting for the genetic key that would let them digest wood. When they finally evolved it millions of years later, the forests would fall silent. For now, though, the song continued. The air shimmered with invisible abundance. Insects darted through the humid glow like sparks in a lantern. Amphibians crawled onto land, their slick bodies glistening with the same water that had once shielded them from flame. Each heartbeat, each breath, each flicker of fire was part of one great, synchronized experiment. The earth, learning how to live with too much of itself, and there was something uncanny about the atmosphere then. Air that dense would have changed sound. Researchers have calculated that in a 35% oxygen world, the speed of sound would increase. Voices would travel farther. Every croak, every flutter, every raindrop striking a fern would echo a little longer. Perhaps that is why the Carboniferous is remembered as the Age of Echoes, a planet that spoke softly through mist and thunder. Yet, beneath the beauty, imbalance was spreading. Fires became too frequent, consuming entire ecosystems before seedlings could recover. The air, once vibrant, grew heavy with smoke and ash. Still, even collapse came slowly, tenderly, as though the planet itself hesitated to interrupt its own masterpiece. Life does not end abruptly. It exhales first, then lingers in the haze of memory. One can almost imagine the last untouched glades, where dragonflies rested on wet leaves under an emerald twilight, unaware that their dominion was fading. In the distance, the smell of burnt peat signaled a shift too vast for any creature to name. The balance was tilting, imperceptibly, but irreversibly. From this threshold, the next act would unfold. The reign of fire and the beginning of decline. The forests, once invincible, would soon meet their match not in drought or cold, but in their own success. The breath of the world had reached its highest note. What follows inevitably is the pause before descent, the moment between inhale and exhale, where silence gathers its strength to become sound again. And somewhere in that silence, the first sparks of change were already waiting. Small, invisible, persistent. The planet preparing once again to rewrite its own lungs. When air becomes fuel, the world learns to burn. The forest that once exhaled peace began to murmur in the language of flame. It started quietly. A flicker on the horizon, a brief shimmer above the canopy. But soon, the entire planet pulsed with combustion. Oxygen, that invisible spirit of life, had crossed its threshold. At 35%, the boundary between breath and fire dissolved. Even the rain could not keep the world from glowing. Imagine a landscape where lightning didn't just strike, it sang. Bolts raked across horizons so dense with vapor and oxygen that ignition followed as predictably as sunrise. Each storm left trails of embers that moved with the wind. Flames crept up the trunks of lycopsid trees, their bark crackling like ancient parchment. Swamps became furnaces. Daylight flickered through veils of smoke that hung like memory, tinted gold and green. The world had entered its age of perpetual fire. Not apocalypse, but renewal, written in heat. Geologists have found the fingerprints of this era in charcoal bands pressed into stone. These layers, scattered across continents, repeat like the rhythm of a heartbeat. Burn, regrow, burn again. Fire became a stabilizing force. It cleared the old, made space for the new, recycled minerals back to the soil, and returned carbon to the air in a pattern so balanced that destruction became indistinguishable from creation. To call it devastation would be a misunderstanding. It was, instead, the Earth's method of breath control. And yet, every equilibrium contains its own dissonance. Fires that once rejuvenated began to rage beyond control. Atmospheric oxygen was now so abundant that damp wood ignited as easily as dry bark. The flames leapt rivers, fed on humidity, and sustained themselves in conditions where, today, combustion would suffocate. In the record of time, this marks the moment when the biosphere began to test the limits of endurance. Some scientists theorize that the frequency of global wildfires may have reached one every few decades, reshaping continents faster than tectonic plates. Still, even in that chaos, life persisted, not despite the fire, but because of it. Evolution, ever opportunistic, began to adapt to flame. Seeds evolved thicker coats that required heat to crack open. Plants grew underground roots capable of surviving the burn and sprouting anew. The Earth was teaching itself resilience, and with every cycle, the air shifted slightly, as if the planet were adjusting the dial of its own metabolism. Fossilized spores and tree resin show that these forests were not silent as they burned. They hissed, released aromatic oils, sent clouds of volatile compounds into the sky. Those same chemicals that made plants fragrant also made them flammable. What we call the fragrance of the forest. Terpenes, resins, and oils were invitations to fire. It is one of nature's quietest contradictions. To attract the flame that will destroy you in order to be reborn. Amid the infernos, insects and amphibians adapted to the changing rhythm. Some took refuge in the waterlogged edges of swamps, where smoke curled gently above the surface, like steam from a giant's breath. Others evolved nocturnal habits, feeding and reproducing in the cooler dark. Dragonflies learned to ride the thermal currents above firestorms, soaring effortlessly on columns of heat. Fire was no longer an anomaly. It had become part of life's choreography. Modern scientists, studying this age, often ask a strange question. Why didn't everything die? With oxygen so high and fire so frequent, one would expect total collapse. But the answer may lie in the delicate balance of moisture and vegetation. The Carboniferous world was endlessly wet, a living sponge. Even as flames devoured its edges, the core remained damp, fertile, protected. Like breath itself, the planet burned and healed in alternating rhythm. An inhale of flame, an exhale of rain. And there's another, subtler pattern hidden in the evidence. After each burn, atmospheric oxygen dipped slightly, only to rise again as regrowth accelerated. Fire was not a catastrophe, but a pulse. The biosphere's way of maintaining a steady state. The planet's breath was self-regulating. It's easy to imagine this world as chaos, but in truth, it was harmony disguised as violence. The same principle survives today. Forests in modern Australia and California still rely on fire to germinate, to fertilize, to remember their boundaries. In their smoke, we glimpse an echo of the Carboniferous song, that deep, slow dialogue between abundance and restraint. Every spark, in its way, repeats the logic of that ancient air. The physical chemistry of the time reveals another layer of mystery. With oxygen at 35%, combustion temperatures were higher, flames brighter and bluer. Night skies may have glowed faintly, The horizon rimmed with distant phosphorescence. Ash drifted across continents, enriching the oceans with minerals, stimulating blooms of plankton that, in turn, released more oxygen. Fire and water, opposites in our modern minds, were then partners in a vast biochemical waltz. In the heart of those wild forests, the concept of safety did not exist. There were only cycles, the slow conversion of light into wood, of wood into flame, of flame into sky. Some amphibians began laying eggs in burrows rather than open pools, instinctively hiding from the constant danger above. Reptiles emerged from that lineage, their scales offering armor against both drought and ember. From flame, the next age of life was born. Every evolution carries a trace of the trauma that caused it. When we look at the genes that control antioxidant production, we are looking at a memory of that era, the body's molecular response to a world oversaturated with air. Even now, every breath we take activates those same ancient defenses. Life never forgets the conditions that once tested its survival. And yet, for all the terror that 35% oxygen invited, the atmosphere also created beauty beyond imagination. After the fires, regrowth came in waves of luminous green. Ferns unfurled from blackened soil like slow explosions of color. The air smelled sharp, metallic, alive. Insects returned before dawn, their wings reflecting the glow of distant embers. To witness such recovery would be to understand the full tenderness of destruction. But every feast of oxygen must end. The soil, once overfed, began to choke on its own fertility. Fires, once self-regulating, grew too frequent, leaving no time for renewal. Carbon, the planet's hidden currency, was being locked away faster than it could be spent. The atmosphere trembled at the edge of imbalance, and so, the Earth, in its strange wisdom, began to change again. Rainfall patterns shifted. Swamps dried into plains. Fungi discovered how to digest lignin, the molecule that had protected wood for millions of years. Decay returned. Carbon that had been buried deep began to rise once more. The oxygen tide that had lifted the world to feverish brilliance would soon begin to ebb. But that is another chapter. For now, we linger in the glow, the final century of endless fire, when the forests still believed themselves immortal, when air was still thick with the scent of creation. Before the silence came, there was music, the crackle of branches, the sigh of burning leaves, the whisper of rain meeting flame. Some say that in those moments, the earth finally learned restraint, not through wisdom, but through exhaustion. Every living thing that survived carried forward the lesson that too much light can blind, too much breath can smother, and that even abundance must know when to fall silent. They called it the Age of Giants, though no one alive today could truly imagine it. It was a world swollen by its own breath. Insects ruled the skies with wings that whispered like sails. Amphibians the size of crocodiles prowled beneath fern canopies taller than cathedrals. Even the soil seemed alive, pulsing with unseen roots that stitched continents together. The earth was young, but its air was ancient, dense, intoxicating, and heavy with potential. Every heartbeat, every ripple of water, every drifting spore was shaped by that one invisible abundance. Oxygen, to breathe then would have been to drink. Each inhalation filled lungs, or gills, or spiracles, with something that felt almost divine. Life responded the only way it could, by growing, expanding, testing the limits of flesh. Size became the language of survival. The larger the body, the more cells could feast on the richness of the air. And so the dragonfly became a hawk, the millipede became a serpent, and the frog-like amphibian became the ancestor of monsters. Fossils whisper this story through their proportions. The ancient Meganeura, a dragonfly with a wingspan nearing a meter, glided effortlessly through the mist. The millipede Arthroplura, armored and deliberate, spanned over 2 meters in length and left tunnels like roads through the swampy soil. Amphibians like Areops and Crassigorinus swam through oxygen-rich waters, gulping air that shimmered with humidity and heat. Even the fish evolved labyrinthine lungs, learning to breathe in a world where the line between air and water blurred. But growth carries consequence. Energy was abundant, but control was not. The very systems that made life flourish began to strain under their own luxury. Insects, for example, relied on diffusion, air entering small openings and spreading through networks of tracheal tubes. The higher the oxygen, the easier it was to sustain enormous size. But diffusion cannot scale forever. As the air thickened, their bodies pushed against invisible boundaries. They reached a biological ceiling, too large to move gracefully, too fragile to survive when the air began to thin again. Evolution, always pragmatic, began to whisper its quiet corrections. Some creatures remained giants for a while, but others shrank even before the Great Decline began. The fossil record hints at fluctuating sizes, as though life was testing its architecture in real time. For every colossal dragonfly, there was a smaller cousin, waiting in the wings for the oxygen tide to fall. Life, even at its most extravagant, was preparing for austerity. Scientists studying ancient respiration have found subtle miracles in these adaptations. The bones of amphibians reveal complex lung chambers that allowed them to breathe more efficiently. Even as oxygen fluctuated, their hearts evolved more chambers, separating blood flows and regulating internal chemistry. What began as indulgence turned into innovation. Too much air had forced evolution to refine its own machinery. The Earth's overabundance was the sculptor of complexity. And yet, for all this grandeur, the forests grew quieter. Firestorms had become frequent teachers. Ash fell like snow over the wetlands, fertilizing new growth but also dimming the sun. The once endless daylight of the Carboniferous now flickered with shadow. Trees competed fiercely for light. Roots dug deeper into the peat, strangling each other in their hunger. The air may have been rich, but the ground was suffocating. There are layers in the fossilized soil where nothing grows. A sudden interruption in the chorus of abundance. Scientists debate whether these silent layers mark droughts, fires, or something stranger. The slow exhaustion of the planet's lungs. The more life produced oxygen, the more carbon it buried, and the thinner the atmosphere became in response. It's a paradox so delicate it feels almost human, creating too much of a good thing until the balance collapses under its own perfection. If one could stand there, in the twilight of that age, the world would appear both eternal and fragile. You would see enormous trees, sigillaria, lepidodendron, calamites, rising into a green fog. Their trunks were hollow, their roots splayed like veins through the mud. Giant insects fluttered between glowing spores. The air shimmered with moisture and heat, but beneath it all, an unease stirred. The giants, magnificent as they were, had built their kingdom on borrowed breath. The atmosphere had reached its peak. Every molecule of oxygen in the sky represented millions of years of buried wood, of decay denied. But beneath the swamps, fungi were evolving. Silent, unseen, microscopic revolutionaries, they were discovering how to digest lignin, the tough polymer that made wood eternal. With that single mutation, the balance of the world began to turn. For the first time, The forest's dead could truly die. Decay returned as a force. The wood that had once sunk intact into anoxic mud now rotted before it could be buried. Carbon began to rise back into the sky, and with it, oxygen began its slow decline. The giants, unaware, continued to breathe deeply, as though the air would last forever. But already, the invisible scaffolding of their world was dissolving. The atmosphere that had nourished them was slipping away, molecule by molecule, breath by breath. Paleontologists find this moment written in miniature tragedies: shrinking body sizes, fewer fire layers, thinner growth rings and fossilized trees. The change was gradual but relentless. The great dragonflies vanished. Amphibians, once supreme, yielded to reptiles that could thrive in drier air. Life was retreating from its fever, learning modesty again. But perhaps retreat is the wrong word. The decline of giants was not punishment. It was transformation. The excess of one age became the foundation of the next. The coal seams buried by those forests would one day power another species' machines, breathing new flame into old carbon. The balance was never lost. It only shifted its form. There's a haunting beauty in that thought, that even extinction serves the rhythm of the planet. The Carboniferous giants never truly disappeared. They were translated. Their bodies became fuel. Their breath became memory. Their time became ours. Every flicker of a modern flame, every spark that lights our homes, is a conversation with those vanished forests. We are still burning their fire. And so, when we study those ancient lungs, the swamps, the oxygen, the living haze of excess, we are not looking at a forgotten world. We are looking at our reflection in deep time. The giants remind us that growth without balance ends not in apocalypse, but in transformation. That every breath is borrowed. That even air can be too kind. The age of giants did not fall in a single cataclysm. It faded, softly, like an exhale at dusk. Forests thinned. The insects' wings grew smaller. The oxygen that had once crowned the world began to drift downward, toward the level we now call normal. And yet, somewhere in that long twilight, life paused, held its breath, and began to imagine a new way to survive. The swamps fell silent before they disappeared. For millions of years, they had been the lungs of the planet, endless, humming cathedrals of ferns, mosses, and colossal trees whose roots gripped continents together. But silence crept through them like a fog. It began with the fungi, small and unseen, unraveling the spell that had preserved the forests from decay. They had learned a forbidden language, the chemistry of lignin, the very molecule that made trees eternal. What once refused to rot now surrendered. The green miracle that had filled the air with abundance began to decompose. This was not a sudden collapse, but a slow, aching unraveling. As the fungi feasted, the balance of breath began to shift. Each fallen trunk that once sank into the swamp now broke apart and returned its carbon to the sky. Oxygen, the world's invisible wealth, started to fade. The same element that had made the forests immortal was now their undoing. The earth had inhaled for too long. The exhale had finally begun. In geological time, it happened quickly, perhaps over a few million years. A blink in planetary rhythm. Swamps that had stretched from what we now call Europe to North America dried into plains. Rain patterns changed, and the once humid atmosphere cooled. Vast forests became patches of struggling vegetation. The age of endless green gave way to a dimmer, more fractured landscape. The evidence lies buried in the coal seams. Before the collapse, The seams are thick, pure, rich with the memory of abundance. After, they thin abruptly. Between layers of black stone appear streaks of gray and rust, traces of oxidation, decay, and drought. The fossilized trunks of lepidodendron and sigillaria end abruptly, as if cut off mid-sentence. Even the spores that once carpeted the air vanish, replaced by pollen grains of smaller, drier plants. Life, ever adaptable, began to shift with the air. Amphibians, the undisputed rulers of the Carboniferous, suffered most. Their moist skin and delicate eggs tied them to the swamp. As oxygen declined and wetlands vanished, their bodies became prisons of memory. Fossil evidence shows their numbers plummeted, replaced by creatures that no longer depended on the kindness of water. From this crucible emerged the first true reptiles, encased in armor and eggshells, carrying their own moisture wherever they walked. It was evolution's quiet reply to a dying world. If the air won't wait, we'll carry our own. But while the forest fell, fire faded too. With less oxygen in the sky, flames grew weaker, rarer. The planet's fever cooled. Its heartbeat slowed. The charred layers in rock, once regular as seasons, became sparse. For the first time in tens of millions of years, rain fell without smoke. The earth had entered its convalescence. The air no longer roared with combustion. It whispered, and yet, this was not peace. It was the aftermath of abundance, the exhaustion after breath. The great experiment of excess was over. The world had learned that too much light can burn. Too much life can drown in its own generosity. The Carboniferous had been a grand improvisation, a planet discovering its own lungs. And now, it was out of breath. Paleoclimatologists trace this turning point in isotopic records, a steady drop from 35% oxygen down toward the low 20s. The difference may sound small, but it changed everything. Insects could no longer sustain their colossal size. Amphibians struggled to breathe in the thinning air. The dragonfly, once a living kite, became just another insect. The giant shrank, not from weakness, but from adaptation. To live smaller was to live longer. To consume less was to endure. Some scientists call this transition the Great Thinning. Others describe it more poetically as the long exhale between one planetary breath and the next. Either way, it was a reckoning. The Earth was recalibrating its chemistry, seeking equilibrium through loss. Fire had written its last verse for now. Decay would take up the melody. Under the microscope, the fossils tell a story almost too elegant to be coincidence. The same decay that released carbon back into the air also fertilized the oceans. As rivers carried nutrients outward, plankton bloomed, pulling carbon back down again. Feedbacks within feedbacks, breath within breath. The planet orchestrating its own recovery. Even collapse, it seems, has purpose. But for the creatures living it, there was no grandeur, no symmetry, only confusion. The air that once shimmered with light now felt heavier. The forest that once sang with insects grew quiet. The amphibians' eggs dried before hatching. Giant millipedes vanished from the record as though erased overnight. Evolution continued. But not all remembered the song. If we could stand there, in the twilight of the Carboniferous, we might not recognize the sky. The light, filtered through smoke and new dust, would have turned copper green. The air would smell of damp earth and the first faint rot of true decay. Each gust of wind would carry the sigh of endings. Not violent, but inevitable. Even the sound of rain would have changed, softer now, falling on leaves smaller and less radiant than before. Yet there is an austere beauty in that decline. Balance was returning. The world that had once burned too brightly now cooled to a more sustainable rhythm. The temperature fell, glaciers grew near the poles, and new ecosystems emerged in the gaps left by the vanished forests. Life was no longer racing upward, it was deepening inward. Reptiles explored dry land, seeds evolved hard shells, and oxygen, though reduced, found its way into steadier cycles. It's easy to call it collapse, but in truth, it was a negotiation. The planet adjusting the terms of survival. What looks like ruin from afar is simply respiration in slow motion. The Carboniferous did not die. It transformed. Its forests became the coal beneath our feet. Its oxygen became the air we breathe. Its silence became the prelude to something new. Perhaps the strangest part is how gentle the end was. No explosion, no asteroid, no flood. Only a long, soft diminishing. A whisper returning to silence. It is tempting to imagine that the Earth sighed with relief, having finally balanced its lungs. But in that balance, something extraordinary had also begun. The first reptiles, dry-skinned and sure-footed, were already carrying the memory of the swamp within them. They would walk into new ages, into deserts and storms, carrying forward the genetic trace of the world that had burned and healed itself. In that sense, nothing was truly lost. The air that once suffocated giants now sustains us. The coal that buried their roots powers our lights. Every breath we take still carries molecules born in that fevered sky. The end of the swamps was not an ending. It was the planet learning how to breathe just enough. And as the fires dimmed, a new kind of silence settled. Not absence, but balance. The Earth, having learned both excess and restraint, was ready for its next experiment. The giants had vanished, but life, wiser now, was waiting in the wings, preparing for the next inhale. The great thinning reshaped the world not only in air but in sound. The once endless crackle of flame and rustle of gigantic wings gave way to stillness. Oxygen had fallen. The skies, once bright and buoyant, became heavier with moisture and dusk. The forests that survived were smaller, quieter, and less ambitious. The planet had inhaled too deeply and now paused to recover. But in that pause, a strange calm settled across the continents. The silence after a fever breaks. Fire retreated first. Charcoal bands in rock layers, once so common, began to fade from the geological record. The planet no longer burned with such frequency. Flame had become rare, almost sacred. The world that once ignited at the faintest spark now resisted combustion. With oxygen levels dropping toward 25%, the equilibrium between air and fire reversed. The same forests that had once feared lightning could now endure its strike without burning. It was as though the planet, exhausted from brilliance, was learning humility. And yet, this humility was not without consequence. The creatures that had thrived on abundance now found themselves starving for it. The dragonflies, whose vast wings had once ruled the skies, struggled to lift their heavier bodies in the thinner air. Amphibians, accustomed to breathing easily through moist skin, began to suffocate. The world's lungs were closing, and only those who could carry their own breath would endure. It was during this time that reptiles, small, dry, and unassuming, began their quiet ascent. They were not the lords of their age, not yet. But their eggs, sealed with hard shells, no longer needed water. Their skin, armored against evaporation, no longer begged the swamp for mercy. They could walk into the dry places left behind by the retreating forests and claim them as home. In their lungs, oxygen flowed efficiently. In their hearts, A new rhythm began. Evolution had found its next vessel. This shift, though invisible to the creatures living it, was monumental. The biosphere was undergoing a complete change of strategy, from excess to precision, from size to efficiency. Nature was rewriting its mathematics. No longer would abundance be measured in height or scale, but in endurance, adaptability, and control. The Carboniferous giants were fading, and the architects of the next stage, the Permian survivors, were taking their first careful breaths. In the sediments of time, this transition looks almost graceful. There are no sharp boundaries, no cataclysms carved into the rock, only a soft, continuous blending of ecosystems. But what the record cannot show is the sense of loss that must have accompanied it. A world that had been full of noise, the hiss of fire, the hum of insects, the groan of trees collapsing into peat, grew quiet. For the first time, the air itself felt empty. The oxygen that had once glowed like a halo around the planet was now simply air again. Invisible, neutral, ordinary. Scientists analyzing fossilized soils from this period describe something almost poetic. Charcoal content drops dramatically, but so does evidence of decay. Life had slowed down, as if the planet were holding its breath. The chemical signatures suggest a lower energy world. Fewer fires, fewer storms, fewer extremes. It was balance through subtraction. Yet, even in this quieter age, something remarkable was happening underground. The decay that had once destroyed the forests now became the foundation of new life. Fungi, microbes, and roots formed complex networks that rebuilt soil. Carbon, having returned to the air, now cycled through living systems at a gentler pace. The earth was no longer a furnace, but a garden. Smaller, perhaps, but wiser. Paleontologists often say the late Carboniferous marks the birth of the modern Earth. The atmosphere stabilized near the 21% oxygen we breathe today. Fire could still burn, but it no longer ruled. Life could still thrive, but it no longer needed to overreach. The planet had found a delicate symmetry, a self-regulating balance between creation and destruction. But stability, as history teaches, is never permanent. The cooling that accompanied this oxygen decline triggered new glaciations near the poles. Ice crept down through what is now South America and Africa, binding water in frozen prisons. Sea levels fell, isolating habitats and forcing migration. The once unbroken forests fractured into islands of life, each an experiment in adaptation. Amphibians vanished from half their former range. Reptiles spread further inland, their footprints pressed into drying mud like signatures of resilience. And then, almost imperceptibly, another change began. In the chemistry of the oceans, as weathering increased, minerals rich in phosphorus and iron washed into the seas, feeding microscopic life. Algae bloomed, drawing down carbon dioxide, cooling the planet further. The cycle of breath continued, but its tone had changed. The atmosphere that had once been an opera of abundance was now a minimalist song of endurance. What fascinates scientists today is not the collapse itself, but its grace. The Earth did not fall into chaos. It adjusted, like a living organism healing its own wound. The fall of oxygen was not an accident. It was balance asserting itself. The same cycles that had inflated the air now conspired to deflate it, pulling the planet back from the brink of eternal flame. If one were to stand on that cooling Earth, it would feel both alien and intimate. The sky would be dimmer, the air crisper, the scent of ash replaced by the mineral tang of stone and rain. The giant trees would stand like ruins, hollow and ancient, their descendants already smaller, humbler, reaching for the same light with quieter ambition. The dragonflies would still fly, but they would no longer cast shadows large enough to startle. The world had taken its breath and released it. It is tempting to see this as an ending, but it was, in truth, an apprenticeship. Nature had learned that unchecked abundance leads only to exhaustion. The lesson would echo across all future ages, in the Permian deserts, in the Jurassic swamps, even in the human world that would come eons later. The planet had discovered the necessity of restraint. From this quiet recovery would emerge the seeds of modern ecosystems, the first conifers, the early ancestors of birds, the genetic memory of endurance. The great thinning was not just the closing of a chapter, but the quiet turning of a page. The earth had survived its own brilliance and found wisdom in simplicity. And somewhere beneath the cooling soil, the last of the old forests continued to breathe, faintly, through trapped bubbles of air. Those ancient pockets, sealed within coal and stone, remained there still, silent relics of an atmosphere that once burned too brightly. The air we breathe today is their descendant, tempered, wiser, carrying the memory of both flame and fall. When we inhale, we are repeating that same rhythm. The same molecules that once filled the lungs of dragonflies now drift through ours. Every breath is history returning, softer now, but still alive. The Carboniferous dream never truly ended. It only learned to whisper instead of roar. After the fires dimmed and the forest withdrew, the world entered a kind of quiet introspection. The air had thinned, the skies cooled, and what had once been a riot of light and heat became a slow dusk stretching across epochs. It was not extinction, but reflection, the planet recalibrating its breath. For a time, life seemed hesitant, as if each new generation were unsure how to exist in this restrained world. But beneath that hesitation, something remarkable was taking shape. Out of the silence that followed excess, evolution began to work with precision. Oxygen had fallen, yet balance had been found. Around 21%, that delicate range between combustion and suffocation. The air stabilized. Fires burned only when invited. Life could breathe without fear of burning from within. For the first time, the atmosphere behaved like a partner, not a wild god. The chaos of abundance had taught restraint. The earth had learned how to inhale gently. In that thinner air, new strategies for survival emerged. Reptiles, small and self-contained, thrived where amphibians could not. Their eggs, dry, sealed, independent, carried life into deserts, uplands, and forgotten corners of the continents. Their skin no longer needed water's forgiveness. They could walk into the sun and keep their breath. Where the swamp had once been the cradle of life, now dryness became the teacher. Evolution began to speak the language of endurance. The great forests of the Carboniferous never returned in the same way. Their descendants grew shorter, tougher, less extravagant. Ferns gave way to seed-bearing plants. Shallow roots dug deeper. The oxygen-rich cathedrals of the past became mosaics of scrub and woodland. Coal was still being formed underground, but the living world above it had changed temperament. Less a symphony, more a steady pulse. The fever had broken, but this moderation came with a hidden consequence. The same oxygen decline that stabilized fire also cooled the world. Ice sheets spread at the poles, locking away moisture, reshaping coastlines. The seas withdrew, exposing wide plains that linked once separated lands. Migration began anew. Creatures wandered, adapted, merged, and competed. It was as if the earth, having quieted its air, now set its continents in motion. We know this time through its fossils, delicate imprints of reptilian feet across ancient mudflats, the ghostly outlines of ferns turned to stone. Even the chemistry of these rocks tells a story of transition. Isotopic analyses show swings in carbon and oxygen that resemble breath itself, the planet inhaling and exhaling through deep time. Each oscillation a reminder that balance is never still, only maintained through movement. And within those movements, intelligence began to glimmer. Not the kind we recognize, but something deeper. A physiological cunning, a metabolic awareness. Species learn to optimize, to regulate, to master the alchemy of breath. Blood chemistry evolved to cling more tightly to oxygen, lungs to draw more efficiently from thinner air. Even plants learned restraint, opening their stomata for shorter intervals to conserve moisture. The Carboniferous had been an age of expansion. The Permian dawned as an age of precision. It is a humbling symmetry, the planet's exuberance giving rise to its discipline. Without the great overbreath of 35% oxygen, life might never have learned to refine itself. The giants fell so that endurance could rise. The forests burned so that balance could be understood. Every ecosystem that came after would inherit that memory. That too much light, too much air, too much freedom always carries a hidden cost. There's an eerie beauty in the geological record from this era. Beneath layers of coal and shale, we find streaks of red, iron-rich sediments oxidized by the changing air. The very color of the Earth changed as the planet's chemistry evolved. Red beds, they're called. The rusting of the world. It was a time when oxygen, now restrained, etched its signature not in flame but in pigment. The soil itself began to breathe in a different way. In the animal kingdom, diversity blossomed even as abundance waned. Early synapsids, mammal-like reptiles, appeared, their rib cages broad and lungs powerful. They were the children of thin air, built to conserve what the giants had wasted. Every heartbeat within them was a quiet victory of design over desire. In their lineage, deep within their bones, the architecture of mammals, and eventually humans, was already encoded. So much of what we are comes from that age of restraint. Our dependence on precise oxygen levels, our fragility at both extremes, even our flame, literal and symbolic, originates there. Fire became rarer after the Carboniferous, but it never vanished. It slept, waiting for another creature clever enough to summon it at will. That inheritance, though still millions of years away, was already gestating in the lungs of small, warm-blooded ancestors that learned to thrive in scarcity. Scientists often call the post-Carboniferous atmosphere modern air, as if the planet finally decided on a recipe and has guarded it ever since. 21% oxygen, just enough to burn, just enough to breathe. A window of existence so narrow that a shift of only a few percent would change everything. That precision is not coincidence. It is memory. It is the echo of ages spent on the knife edge between creation and collapse. And in that memory lies a quiet question. How does a planet remember? Through rock? Through biology? Or through something subtler? A resonance in the air itself? Because the balance that sustains us is not static. It hums, it oscillates, it negotiates with every volcanic eruption, every burst of photosynthesis, every human breath. The Earth learned moderation once. It can forget. As we breathe this same mixture, the descendants of those ancient gases, we are participating in the same dialogue. The air we exhale now once filled the veins of dragonflies, the roots of lycopsids, the lungs of the first reptiles that dared the dry wind. The molecules that sustain us are the survivors of every imbalance that ever was. If you listen closely to the world at dusk, when the wind falls quiet and the leaves barely move, there is still an echo of that long-ago silence. The hush that followed the collapse of the Green Empire. It's the sound of the planet remembering how to breathe properly. The oxygen that once burned forests now hums softly in the background of our existence. A fragile equilibrium we rarely notice, but depend upon completely. In the grand story of life, the fall from 35% to 21% was not a tragedy. It was an act of mercy. The world saving itself from its own brilliance. The forests may have vanished, but the principle they discovered remains. That balance is born not from abundance, but from the ability to endure less. The earth had exhaled, finally, after millions of years of breathless creation. And in that long, quiet pause, something extraordinary began. The slow rise of resilience, of thought, of awareness. The fever had broken, but the dream continued, transformed. When the balance finally settled, the air carried a strange stillness. Not absence, but composure. The fires had cooled, the swamps had dried, and life moved more carefully now, as though remembering what excess could do. The oxygen that once roared like a god had quieted into partnership. No longer a force of chaos, it became something subtler, the steady rhythm that would cradle everything that followed. And in this tempered world, life began its next experiment. Rebuilding from humility, the Carboniferous had been an age of giants and abundance. The Permian, which followed, was an age of refinement. Evolution began to trade grandeur for complexity. Muscles became more efficient, lungs more intricate, circulatory systems more selective. Organisms no longer relied on abundance but on mastery of scarcity. What had once been automatic, breathing, burning, growing, now required precision. In the thinner air, every heartbeat mattered. It was here that the foundation of the modern biosphere was set. The great amphibian empires of the Carboniferous dissolved, replaced by the confident gait of reptiles. Cold-blooded, self-contained, unbothered by drought or distance. Their eggs, protected by shells, carried life into new territories untouched by water. Their lungs, more advanced than their ancestors, could extract oxygen from the air with exquisite efficiency. The world, still vast and quiet, belonged to them, but this calm was deceptive. Beneath the crust, the earth was stirring again. As the continents drifted toward one another, they began to fuse into a single supercontinent. Pangaea. Vast, dry, and brutal. The green continents of the Carboniferous merged into red deserts, streaked with salt and dust. The air above them shimmered, heavy with heat and distance. And though oxygen remained stable for a while, the chemistry of the planet was changing. The forests that had once covered the world retreated to the edges, near coasts, rivers, and humid belts. In their place rose conifers, plants built for survival, with needles instead of leaves, resin instead of sap. They did not burn as easily, nor rot as quickly. They were the trees of restraint, the architects of a new equilibrium. The lush, suffocating air of the Carboniferous was gone. The atmosphere now breathed in moderation. Scientists studying the fossil record see this shift as both biological and psychological, as though the planet had learned patience. Oxygen concentrations remained near the modern 21%, but carbon dioxide levels began to swing. Ice advanced, then retreated. Rain became sporadic. Whole regions that had once drowned in wetlands now cracked in the sun. And through all of it, life persisted. Each new adaptation carried the memory of the old extremes, as though remembering not to repeat them. It is in these fluctuations that we begin to see the deeper intelligence of the biosphere. Not conscious, but responsive. The Earth's systems, from microbes to mountains, were learning to self-regulate. Every rise in oxygen triggered new feedbacks. Increased fire, reduced vegetation, carbon released, oxygen drawn down. Every decline in oxygen slowed decay, inviting regrowth. The world had discovered the breathing rhythm that still sustains it. Not constant, but cyclical, like a sleeping giant's chest rising and falling through time. The air we know today, 21% oxygen, 78% nitrogen, traces of everything else, was not an accident. It was sculpted by trial, by combustion, by collapse. It is a balance so narrow that it almost feels deliberate. Any less oxygen, and fire would die. Any more, and everything would burn again. That tightrope defines life itself. In this age of moderation, evolution's attention turned inward. Instead of expanding, it began to refine. Warm-bloodedness appeared, a trick of metabolism that allowed some creatures to generate their own heat, to regulate their internal fire. This was oxygen's new role, not to inflate the body, but to animate the spirit. Fire, once external and devouring, now lived within the bloodstream. The ancestors of mammals carried it first, a small controlled flame burning behind the ribs, consuming oxygen in quiet efficiency. What had once fueled forests and infernos now fueled thought. The link between oxygen and consciousness was beginning to take shape. To breathe was no longer just survival. It was awareness. Each inhale delivered not just air, but the potential for memory, movement, imagination. Scientists studying the evolution of metabolism note a strange symmetry. As atmospheric oxygen stabilized, brain size began to increase in certain lineages. Energy that once went into sheer size was redirected into neural complexity. The giants of the swamp had fallen, but their legacy, the chemistry of abundance, had made this new subtlety possible. It was as though the world had traded muscle for mind. In the rocks of this time, iron tells the tale. Iron rusts only when oxygen is present, and the planet's crust is streaked with that memory. Layers of oxidation marking each breath of the earth. Beneath those layers lies coal, the compressed ghosts of forests that once ruled the skies. Between them, a message emerges, that every abundance must one day condense into wisdom. The air we breathe now is not the first atmosphere to learn this lesson, only the most recent one to remember. But the Earth's memory is never linear. It loops, echoes, forgets, recalls. After the Carboniferous and the quiet stabilization that followed, there would be new upheavals, volcanic winters, glacial ages, sudden warming. Oxygen would rise and fall, never straying too far from its hard-earned balance. Each fluctuation was a reminder that control, in nature, is never total. The planet does not seek perfection, only endurance. Perhaps that is why the air feels ancient even when it's fresh, because it has been through everything before. Every molecule of oxygen in your lungs right now has burned in a fire, flowed through a forest, dissolved in an ocean, or circulated through the blood of something that lived and died long before humans were imagined. Breathing is not an act of consumption. It is participation in an ancient continuity. If the Carboniferous was the Earth's great inhale, then what followed was its long, patient exhale. Not a collapse, but a deep release. The air had been too rich, too fierce, and now it was learning softness again. Each breath became a negotiation between abundance and absence, flame and ash, memory and forgetting. The world had reached its middle age, wiser, quieter, balanced on the edge of its own awareness. And somewhere in that calm, beneath the slower rhythm of oxygen and time, new possibilities were gathering. Small creatures with complex lungs, the beginnings of warm-blooded thought, the earliest whispers of intelligence flickering behind tired eyes. The fires outside had gone, but a subtler fire had taken their place, one that would never again be extinguished without consequence. The world had survived its fever, but it was not the same world anymore. The atmosphere, once a roaring engine of flame and growth, had slowed into something almost contemplative. The air had become transparent again, not thick, not shimmering, but calm. The planet seemed to sigh after its long labor, its breath gentler now, as though afraid to wake the ashes it had buried. It was an age of restraint, an age of repair. And though the skies were quieter, beneath them, the earth was remembering. Oxygen had become more than chemistry. It was memory, invisible, omnipresent, layered into everything that lived. The survivors of the Carboniferous carried that memory in their blood, in their lungs, in the shape of their bones. They had endured both abundance and scarcity, and in doing so, they had learned the secret rhythm of balance. It was not a story of dominance, but of endurance, of learning to live with less and live longer. The reptiles that had once crept timidly through the ashes now walked openly beneath cooler suns. Their lungs, shaped by scarcity, drew air with precision. Their blood, rich in hemoglobin, carried oxygen farther, deeper, slower. Evolution was sculpting patience into biology. The new world rewarded subtlety over spectacle. And yet, even in this era of balance, the echoes of the old world lingered. The coal beds beneath the continent still whispered with trapped oxygen. The fossilized sighs of forests that had once touched the clouds. Deep underground, the ghosts of those trees were transforming. Compressed by time. Heat and pressure into the black veins of carbon that would one day power civilizations not yet imagined. In every piece of coal lies the memory of that over-breathing planet. Each spark we strike today is a resurrection of ancient air. The surface world, however, moved on. The new vegetation, conifers, cycads, ginkgos, rose in slender spires rather than massive trunks. They were designed for endurance, their waxy needles preserving moisture, their seeds built for travel. The atmosphere they exhaled was steady, predictable, modest. Fire still existed, but it no longer ruled. It had become a seasonal visitor rather than a sovereign. The earth had learned to keep its distance from its own fire. Geologists and paleobotanists studying the fossils of this time often describe an uncanny calm. The rock layers between the Carboniferous and the Permian lack the drama of mass extinction or cataclysmic eruption. Instead, they show a slow drift toward simplicity. Ecosystems reduce their scale, species specialized, and stability, that rarest of planetary conditions, took hold. But this stability was not eternal. It was an interlude, a quiet heartbeat before the next storm, because deep within the earth, beneath the crust that cooled and cracked, another kind of fire waited. Volcanic activity in the coming ages would again change the chemistry of the air, testing the fragile peace the planet had achieved. But for now, the world exhaled in rhythm. The oxygen, steady at around 21%, became the planet's equilibrium point, a balance between what burned and what breathed. This balance had consequences far beyond fire. With oxygen levels stabilized, metabolism evolved toward complexity. Cells learn to harness the molecule more efficiently, channeling its energy into endurance and precision rather than expansion. Warm-bloodedness, first a fragile experiment, became an advantage. The steady air allowed for steady hearts. In this way, oxygen not only sustained life, it began to define its tempo. Modern scientists sometimes speak of this as the oxygen revolution, though it unfolded in near silence. Over millions of years, small changes in oxygen levels influenced the evolution of everything, from the diameter of animal lungs to the shapes of leaves. Even behavior shifted. Creatures that could move slower, conserve energy, and regulate their breath began to outlast those that still burned too quickly. The planet had learned to favor the patient. We tend to imagine oxygen as a constant, an invisible backdrop to existence. But in truth, it has never been constant at all. It rises and falls with every epoch, sculpted by forests, oceans, volcanoes, and time. The 21% we breathe is not a given. It is an accident of restraint. A balance achieved not once, but endlessly. Renewed and recalibrated through every crisis the Earth has endured. In that realization lies something profound. The same molecule that once unleashed infernos is the same that allows thought. Oxygen both builds and erases, nourishes and consumes. Its dual nature is a reminder that life itself is born from contradiction. Too little, and the world suffocates. Too much, and it burns. Somewhere between those fates lies the narrow window where meaning happens, where breathing becomes awareness. As the Permian world continued to evolve, the forests pulsed quietly with photosynthesis, each leaf a clock keeping planetary time. The air was a living archive, every gust carrying molecules recycled through eons of growth and decay. Even now, when scientists measure ancient air, trapped in rock pores or ice cores, they find echoes of those early atmospheres. Tiny bubbles of the Carboniferous still sleep in Antarctic ice, waiting to tell their story. That story, at its heart, is not one of extinction or survival, but of rhythm. The planet breathes in cycles. Oxygen rises, fire spreads, decay returns, oxygen falls, ice grows, and life adapts again. It is a pulse older than any civilization, older than continents, older even than the sun's steady light. To exist within that pulse is to belong to something vast and endlessly self-correcting. The animals of this era would not have understood that rhythm, but they lived by it nonetheless. Each inhale of the new, thinner air carried the legacy of 35% oxygen, the overabundance that had once both blessed and cursed the world. Every lungful was a lesson. Even now, in us, that memory remains. Our bodies are calibrated to that ancient compromise, that fragile middle ground between too much and too little. And so, the story of oxygen becomes the story of balance itself, a chemical truth that became a spiritual metaphor. To breathe is to participate in the same experiment that once filled the world with giants and then took them away. Every inhale is an echo of abundance. Every exhale, an act of restraint. As the age continued, reptiles flourished, insects adapted, and the forests spread again, smaller but wiser. The planet had found its breath, not the wild gasp of creation, but the measured cadence of maturity. For the first time, the earth felt old, not weary, but knowing. It had burned, it had healed, it had learned the cost of breath, and though countless ages would follow, ice, fire, extinction, rebirth, this was the moment the world learned to endure itself. The lesson remains suspended in the air we breathe tonight. That balance is not a gift, but a discipline. The Carboniferous gave us the oxygen. The aftermath taught us how to deserve it. The Earth's breath had steadied, but it was never still. Even in balance, motion persisted. Silent exchanges between ocean and sky, forest and flame, rock and root. The thin blue veil of atmosphere that wrapped the planet shimmered with invisible negotiations. The give and take of gases that determined everything that could live or die. For the first time, the world had achieved a kind of equilibrium. Yet it pulsed with unseen restlessness. Oxygen had found its voice, and that voice spoke in rhythm, not silence. The forests of the Permian were different from the green cathedrals of the Carboniferous. They no longer soared endlessly into the mist but stood apart. Wider spaces between trunks, less shadow, more light. Air moved freely again. The leaves had changed too. Smaller, tighter, built to preserve water, to endure drought rather than drown in abundance. Each was an act of discipline, a record of what the world had learned. Gone were the reckless giants that reached for heaven. In their place grew the patient ones that reached for tomorrow. Fires no longer roared through the continents, but they never vanished entirely. They appeared like punctuation, brief, deliberate, regenerative. In their smoke, the air tasted familiar, like a ghost from the Carboniferous whispering through the new Restraint. Fire had not been defeated. It had been tamed. It had found its place in the new order. No longer an enemy of life, but its regulator. And beneath these forests, unseen but constant, the planet's memory deepened. Carbon that had escaped into the air now drifted down again, pulled by gravity, water, and time. Layer upon layer, it pressed into stone, into coal, into the black veins that ran beneath the continents. The Earth was writing its autobiography, in ash, in carbon, in oxygen. The pages of that book would one day be read by creatures capable of wondering who wrote it. The oceans, too, had changed. Their chemistry stabilized. Their color deepened. With oxygen flowing steadily into their upper layers, marine life blossomed anew. Algae shimmered beneath the waves, photosynthesizing tirelessly, maintaining the delicate balance between oxygen and carbon dioxide. Tiny plankton, unseen but essential, became the quiet governors of the planet's breath. The same process that once filled the skies now pulsed invisibly under the surface. A parallel biosphere of respiration and return. It was during this long exhale of planetary calm that the building blocks of complexity truly flourished. The stability of the atmosphere allowed for longer lifespans, greater specialization, more intricate ecosystems. The machinery of life, powered by oxygen's steady flame, began to diversify into forms that would one day become familiar. Reptiles with sharper senses, plants with deeper roots, insects learning the geometry of flight. The chaos of abundance had evolved into choreography, yet stability carries its own fragility. The Earth's system is a balance beam, and every equilibrium invites its own disturbance. Beneath Pangaea's vast deserts, volcanic forces gathered, slow and immense. For millions of years, the landmass baked under relentless sunlight, and the air above it began to dry. Dust traveled where forests once grew. The once green continents were turning red, oxidized, arid, ancient. The same oxygen that had once empowered life was now rusting the world itself. Geologists call these formations red beds, and they mark a profound shift in planetary chemistry. Iron in the soil, once bound in reduced form, reacted with the oxygen-rich air and turned scarlet. It was the planet's great oxidation etched into color, the soil itself breathing, Every grain of red dust carried a story of reaction, of the marriage between earth and air. From that moment on, rust became the signature of time. Even the creatures evolved to match their new oxidized world. Reptiles' blood, rich in iron, mirrored the same chemistry that painted the deserts around them. Oxygen no longer shaped them through abundance, but through necessity. They grew efficient hearts, slower metabolisms, thicker skins, everything tuned to survival in a leaner world. It was as if life and planet had entered a dialogue, each refining the other toward resilience. To scientists today, the fossil record of this period reads like a sigh between storms. No great catastrophe yet, only the faint trembling of what was to come. Oxygen levels remained near their steady 21%, but methane declined, carbon dioxide dropped, and the planet cooled further. Snow crept down from the poles, glaciers advanced, and once again, the Earth prepared for correction. Balance, it seems, is never permanent. It is a rhythm of reaching and returning, of overshooting and healing. And yet, in this cool, measured age, something unseen was brewing. Complexity of mind. Small synapsids, ancestors of mammals, scurried beneath the conifers, carrying with them an internal revolution. Warm blood, higher metabolism, longer endurance, all of it made possible by the oxygen their ancestors had once squandered. Each tiny heartbeat was a continuation of that ancient chemical story, translated now into instinct and awareness. They lived quietly, in the shadows of larger reptiles, unnoticed, yet enduring. Their existence proved that evolution no longer needed spectacle. The grand experiments of the Carboniferous, size, flame, abundance, had given way to the subtler experiments of longevity and focus. These small, resilient creatures would outlast empires of giants yet to come. In their breath, the story of oxygen's discipline continued. If one were to stand upon the Permian plains, the air would feel eerily familiar. It would fill your lungs as it fills them now, not too thin, not too rich, carrying the faint tang of resin and salt. The wind would whisper through pine-like trees, brushing dust across red stone. Overhead, the sun would burn steady, filtered through an atmosphere that had finally learned balance. The sky would look almost modern. You could stand there, millions of years away from yourself, and breathe as if nothing had changed. But of course, everything had. The air was no longer wild. It was curated by memory, the accumulated wisdom of eons, encoded in the chemistry of the sky. Oxygen had found its equilibrium, and with it, life had found the pace it could keep. The fires had gone inward. No longer a planetary blaze, they now burned quietly in hearts and cells and thoughts. The story of 35% oxygen was no longer visible in the trees or the insects or the color of the horizon. It had become invisible, absorbed into the silent processes that sustain existence. The age of extremes had given way to the age of subtlety, and that subtlety would last until the planet, as it always does, began to shift again. For the moment, though, the Earth was content. It had inhaled, exhaled, survived, and learned. The forest no longer reached for the sky, but the roots had grown deeper. The air no longer glowed, but it was clear. The fires no longer consumed, but they burned inside every living thing. And in that stillness, in that narrow window between chaos and silence, the world rested, as if gathering breath for the next chapter. The oxygen had found its balance, but balance was never the end of the story. It was only the beginning of everything that could come after. Balance never means stillness. It only means waiting. The Earth had found its rhythm again, its oxygen steady and its fire subdued. But beneath that calm, pressure was building. In the silence of the Permian world, continents fused, oceans shrank, volcanoes stirred, and the planet began to murmur in its sleep. The air, still gentle, would soon be tested once more. For though oxygen had learned restraint, the world beneath it had not. The surface told one story. A planet healed, breathing evenly after its long fever. But the interior told another. Magma moved restlessly beneath the supercontinent of Pangaea, trapped heat searching for release. The crust thickened under its own weight, and fractures spidered through deserts of red sand. In time, those fractures would become the scars of the next great undoing. A slow, invisible tension rising toward eruption. Yet, above, the skies remained deceptively peaceful. The forests of conifers and seed ferns spread across the highlands, their roots reaching deep into iron-rich soil. Rivers carved new paths through the plains, carrying rust-colored sediment into shallow seas. The world glowed faintly under a veil of reddish haze, the color of oxidized dust. This was not the emerald radiance of the Carboniferous. It was the burnished light of maturity. The planet, at last, looked its age. Life, too, wore the face of patience. The reptiles, now masters of land, had diversified into hunters and grazers, armored and agile alike. Synapsids, the warm-blooded precursors to mammals, moved through forests in quiet purpose. They did not rule, but they endured, carrying the secret of endurance within their bones. The air they breathed was enough, not rich, not sparse, but measured. It had taken hundreds of millions of years for the atmosphere to perfect that number. The narrow corridor where fire lives but does not reign. Modern scientists describe this equilibrium with awe. 21% oxygen is not a coincidence. It is a consequence. The planet's chemistry, its living mantle of vegetation and sea, had fine-tuned itself into a feedback system of astonishing precision. Too much oxygen, and fire would erase the forests. Too little, and breath would falter. So the Earth learned to hold its breath at the edge of flame, a balance so fragile that it feels almost deliberate. But no equilibrium lasts forever. Around 252 million years ago, the world entered its next convulsion. It began in the shadows, a slow poisoning of air and sea. Volcanic fields erupted across what is now Siberia, belching carbon dioxide and sulfur into the sky for hundreds of thousands of years. The oxygen, once steady, began to drop. Acid rain fell across the deserts, bleaching the soil. Oceans warmed and thickened, losing their ability to hold breath. The planet's lungs began to close again. Geologists call it the Great Dying, the largest mass extinction in the history of life. More than 90% of species vanished. Coral reefs dissolved, forests collapsed. Insects disappeared from the fossil record for millions of years. Even the atmosphere itself seemed to fade. Oxygen fell to levels not seen since before plants had colonized land, perhaps as low as 12%. It was as if the Earth, exhausted from cycles of abundance and restraint, had finally exhaled everything it had left. But in the language of deep time, even catastrophe is a kind of punctuation, an interruption, not an ending. From that silence would rise the world we know. The age of dinosaurs, of birds, of mammals. The Great Dying was not merely destruction, it was transformation. The biosphere was rewriting itself again, using oxygen as both pen and eraser. In that moment of collapse, The dual nature of oxygen became painfully clear. It is both the giver and the thief of life. It builds cells, but it also corrodes them. It sustains breath, but it feeds fire. The same molecule that once allowed the forest to flourish had also made them combustible. In the Great Dying, that duality returned. A reminder that nothing on this planet is ever simple. For the species that survived, adaptation became prayer. Some creatures evolved more efficient respiratory systems. Others retreated to the sea, where oxygen still dissolved in the waves. The survivors carried forward the lessons of imbalance, encoded in their blood chemistry, their lungs, their instincts. Evolution remembers through structure what memory cannot preserve through mind. It would take tens of millions of years for the air to recover. Slowly, photosynthesis resumed its patient work, drawing carbon from the atmosphere and restoring oxygen to the sky. The balance climbed again, not to the wild highs of the Carboniferous, but to the stable breath of moderation. The Earth, scarred but alive, inhaled once more, and though this new atmosphere would belong to different rulers, to reptiles that would grow into titans and birds that would inherit the sky, the chemistry of that air remained the same song. The pulse of breath, the rhythm of burn, the discipline of renewal. The giants of the future, the dinosaurs, would move through an air forged from memory and loss. Every breath they took was borrowed from the ghosts of forests that had burned long before they existed. When scientists study the mineral record of this transition, they find evidence not only of destruction, but of repair. Iron oxidized again as the air cleared. Charcoal reappeared in sediments, a sign that fire had returned, but in moderation. Oxygen levels, once starved, rose back toward the living range. The planet's lungs reopened, cautious but steady. The world had survived itself, and in doing so, had proven the resilience of breath. It's strange to think that the same molecule flows through us now, that the air we draw in each night carries atoms forged in volcanic skies and ancient storms. We inhale the remnants of every atmosphere the Earth has ever known. Each lungful contains fragments of forests that once glowed green under higher suns, of oceans that breathed before coral existed, of creatures that inhaled 35% oxygen and exhaled extinction. The air is not just around us, it is history itself, endlessly recycled, endlessly alive. And so the story of oxygen is not only about chemistry, but about endurance, the patience of balance, the humility of survival. The planet has learned again and again that breath must be earned. Each rise of oxygen invites flame. Each fall demands adaptation. Between them lies the narrow corridor where life endures. Fragile, temporary, infinite in repetition. In that corridor, we now stand. Every breath we take repeats a pattern 400 million years old. An inhale of generosity, an exhale of restraint. The Earth's lungs, vast and invisible, continue their rhythm, remembering, forgetting, and remembering again that too much of anything, even air, can become a kind of fire. The world that rose after the Great Dying was quieter, emptier, and strangely lucid. The air was thin but clean, stripped of its excess, rebuilt from ruin. The ocean shimmered with ghostly plankton blooms, rebuilding the planet's breath molecule by molecule. On land, the silence must have felt infinite. For the first time in hundreds of millions of years, there were no forests thick enough to darken the horizon, no insect hum to fill the twilight, no chorus of amphibians calling from unseen pools. Only wind, only dust, only recovery. But out of that silence came clarity. The air, though sparse, was stable. Oxygen levels began their slow climb once more, guided by the quiet industry of photosynthesis. A miracle that never truly ends. Cyanobacteria and algae, ancient custodians of breath, resumed their work with monastic patience. Their tiny bodies shimmered in sunlight, breaking apart water and carbon dioxide to release the same invisible gift that had once nearly destroyed the planet. Oxygen. It was as if the Earth, even after collapse, could not stop breathing. The continents, too, were rearranging themselves. Pangaea's heart baked under endless sunlight, but its coasts began to bloom with life. Primitive ferns and seed plants crept back across the floodplains, followed by insects, small reptiles, and new species of amphibians. Smaller now, leaner, designed for efficiency. Life had learned its lesson. No more giants, no more indulgence. In a thinner atmosphere, only those who mastered limitation could endure. And then, slowly, the forests returned. Not the same green cathedrals of the Carboniferous, but humbler versions. Conifers, cycads, and ginkgos rising through red soil. Their roots held the earth together again. Their leaves drew down the last of the volcanic carbon, exhaling steadier air. In those forests, the oxygen of the future took its first measured breaths. Geologists reading these rock layers describe a world stitched back together by patience. Carbon ratios in ancient sediments show the slow rhythm of photosynthesis rebalancing the sky. Each layer, a line of recovery. Each fossilized leaf, a letter in the long apology of the earth. The air that emerged from this process was not one of luxury, but of moderation. A breath that would last. It is difficult to imagine that from this fragility came everything that followed. The dinosaurs, the birds, the mammals, and eventually us. All of it born from the restraint learned after excess. The post-Permian world was a classroom, and oxygen the teacher. Its lesson was simple. Too much abundance destroys. Too little abundance starves. Survival lies in the quiet between. In this new atmosphere, fire returned, cautiously at first. Charcoal begins to reappear in the fossil record, but in delicate traces. It was a softer fire, a collaborator rather than a tyrant. The forests no longer burned endlessly. They burned rhythmically. Fire became part of the cycle of renewal again, a necessary pruning rather than annihilation. Oxygen had found its companion in control. If we could stand there, in that early Triassic dawn, the air would taste familiar, but slightly different. Drier, lighter, less sweet. The sky would be an austere blue. The forests would hum with smaller, subtler life. Where the Carboniferous world had overwhelmed the senses, this one would soothe them. It was the same planet, but wiser. The chemistry of humility. And yet, beneath that calm, the pulse of evolution quickened again. The smaller reptiles diversified into hunters and foragers, their bodies sleek and efficient. Some grew scales that reflected the heat. Others evolved faster metabolisms. Oxygen, though modest, fueled invention. It had become the element of precision rather than excess. The age of muscle was over. The age of design had begun. Even the oceans, once suffocating from volcanic heat, began to bloom with new complexity. Coral reefs returned, rebuilding from calcium and memory. Tiny shells formed in the shallows, turning the chemistry of seawater into architecture. Every ripple, every wave was part of the same slow conversation between air and life. The planet was breathing deeply again, not in haste, but in rhythm. Scientists studying the isotopic signatures of this recovery find something remarkable. Small oscillations, cycles of oxygen rising and falling every few million years, almost like a planetary heartbeat. The Earth's breath, it seems, never truly stabilizes. It expands, contracts, adjusts, and learns. It is a living system, improvising its way toward balance. Each surge of oxygen births new complexity. Each decline prunes what cannot adapt. Creation and destruction are not opposites. They are inhalation and exhalation. The post-extinction world was a landscape of quiet miracles. The first ancestors of mammals scurried under conifers, their warm blood burning with the faint echo of the old 35% air. An inheritance now tempered into warmth instead of fire. Their lungs were small furnaces of memory. Above them, early archosaurs, distant ancestors of dinosaurs and birds, began to test new shapes of motion, learning how to run, how to leap, how to master endurance. Oxygen, though restrained, gave them power through patience. For millions of years, this new balance held. Oxygen hovered around its steady point, supporting ecosystems vast yet controlled. Forests expanded and receded in rhythm with ice and drought. Fire visited, but never conquered. The planet had entered its mature phase. Not youthful and reckless, not senile and inert, but balanced in wisdom. It's easy to forget, looking at the sky today, how fragile that equilibrium really is. A few percent higher, and the world would again be flammable. A few percent lower, and every breath would labor. The air we depend on is the result of endless negotiation between oceans, volcanoes, forests, and the invisible armies of microbes that never stop shaping our fate. The atmosphere is not background. It is the protagonist of Earth's story, and yet, this balance is always temporary. In the fossil record, every calm period hums faintly with foreshadowing. Pressure builds in silence, and new upheavals follow. The Triassic calm would not last. Deep below, tectonic rifts widened, and magma stirred once more. But before the next firestorm, there was this. A fragile golden age when the Earth finally understood itself. In that quiet window, the air we breathe today was born, refined, purified, practiced. Every breath we take is a repetition of that long recovery, that planetary discipline learned through fire and loss. We are inhaling history, exhaling its continuation. The world does not forget what oxygen has done to it. It remembers in every rusted stone, every layer of coal, every flicker of flame. It remembers in us, in our blood that still binds to oxygen as if in reverence, in our breath that mirrors the same inhale and exhale that once shaped the sky. And somewhere in that rhythm, between the memory of abundance and the echo of extinction, the Earth still listens to itself, breathing quietly, as it always has, on the edge between too much and too little.